9.2 Finding Mass of Isotopes, Chunk and Chew. Remember the definition of isotope? Isotopes are atoms of the same element, same protons, with different numbers of neutrons and therefore different masses. Protons and neutrons each have a mass of 1 AMU. Electrons have 0 mass. That means the mass of an atom is equal to the total number of protons plus neutrons. Mass equals P plus N. So if the electrons have no mass, then the mass is just the protons plus the neutrons. Guiding question, why do isotopes have different mass? The example here, let's walk through that together. Oxygen, we see a periodic table square here. And remember that the atomic number tells us the number of protons. And then on the table, we also see the average mass. But we don't want to use the average. We want to find the mass of a certain isotope of one atom. So looking over here, isotope A, we're going to find the mass. So I see in the nucleus here 8 protons and 10 neutrons. We said mass equals protons plus neutrons. So I'm showing my work here. 8 protons plus 10 neutrons equals 18. There's a reminder highlighted in blue. Don't add the electrons because they have 0 mass. So we're just focusing on the nucleus here. And we're focusing on the P and the N, the protons and the neutrons. So the mass of isotope A is 18 AMU. And then to practice the isotope names, oxygen-18 is the name of this isotope. Now I want to think about that average a little bit. So it says this mass is higher or lower than the average mass of oxygen. And I've already filled in higher, but let's see, how do we know that? The mass here is 18. And remember over here, the average mass, it says 15.999. So 18 is higher than average. So this isotope has more neutrons than most oxygen. It's higher mass because of those extra neutrons. Let's look at the next one. Isotope B over here, and its mass. So this time we see 8 protons again, and only 7 neutrons. 8 plus 7 is 15. So the mass of isotope B is 15 AMUs. It's still oxygen because the atomic number 8. Protons are 8, so that means it's oxygen, but it's oxygen-15. So remember, the mass is how we distinguish between them. Since they're both oxygen, we use the mass because that's something that's different. And comparing back to the periodic table, this mass is lower than the average mass for oxygen. Not a lot lower, but 15 is lower than 15.999. So this oxygen maybe has a little less neutrons than normal. Continue that way, following the example above with hydrogen. I'll do one more with you, or you can pause and try it on your own. So I'm going to show my work. I'm going to remember, focus on the protons and neutrons. So in this picture, I see 1 proton, and I do not see any neutrons. So I'm just going to put plus 0. 1 plus 0 is 1. So this hydrogen has a mass of 1, and the unit AMU. And so its name is hydrogen-1. And this mass is higher or lower than the average mass for hydrogen. 1.008 is the average. 1 is just a tiny bit lower than that. Then on the next one, this is still hydrogen because it's still got one proton, but this time there are two N's there, two neutrons. So 1 plus 2 equals 3. The mass of this one is 3 AMU. So it's still hydrogen because one proton. And for all of these, they're always the same element, but they're isotopes of each other. They're like twins in the same family. So they're the same family, hydrogen. This one is hydrogen dash 3 because of the mass of 3. And this mass is higher or lower than the average for hydrogen. Well, the average was 1.008, remember? So this time it's quite a bit higher. All right, don't make this harder than it is. Just add up those protons and neutrons and you'll be fine. I'm going to skip ahead now to the second section if you want help with this. What if we know the mass but don't know the number of neutrons? Can you rearrange the equation? So up here, we knew the protons and neutrons, but we didn't know the mass. But what if we know the mass? So how to find the number of neutrons using the mass? Remember, the atomic number equals the protons. So here the atomic number is 3. So that means the protons are always 3 for lithium. And the isotope name tells you the mass. So lithium 8, over here now, lithium 8 means the mass is 8. Do not use the average mass that's on the periodic table. This average is for all lithium atoms. We want to just focus on this one lithium atom, lithium 8. We can rearrange the equation we used earlier to this. Neutrons equal mass minus the number of protons. So again, shortening it up, neutrons equals mass minus, actually I'll change the color, minus protons. All right. So the example here is for lithium all the way across. These are all isotopes of lithium. I'll just read that, like lithium 6, lithium 7, lithium 8. So to find the protons, it's the atomic number. How many protons? 3. Notice that's the same for all of them because they're all lithium. Remember, isotopes are the same element, which means same protons as each other, but they have different neutrons. So for the neutrons, we have to do N equals mass minus proton. So in this case, the mass is 6, and the atomic number is the same as the protons. So 6 minus 3 means there are 3 neutrons here for isotope A. We don't have a picture of that isotope, but you could imagine then it has 3 protons and 3 neutrons in its nucleus. Going to isotope B here, lithium 7, the mass this time is 7, but the atomic number is still 3 because it's still lithium. So this time protons are 3, but neutrons are 7 minus 3, or 4. So this one has 1 more neutron than lithium 6 did, and that's why it weighs 7. Imagine that atom then with 3 protons and 4 neutrons in the nucleus. And finally, the lithium 8 over here has a mass of 8, and the atomic number is still 3. And so protons are easy. That's always the same as the atomic number, 3. But the mass minus the atomic number this time is 8 minus 3, or 5 neutrons. So imagine that atom has 3 protons and 5 neutrons in its nucleus. So these 3, lithium 6, lithium 7, lithium 8, are isotopes of each other. They're kind of like triplets. They've got the same number of protons as each other, but they have different numbers of neutrons. Let's do one more. So boron 9. how many protons. I don't get the protons from the name as easily. I have to go over and look at the periodic table. So boron is atomic number 5. Remember, that is going to give me the protons. So there's 5 protons. And then to find the neutrons, I'm going to do the mass minus the atomic number. So boron 9 has a mass of 9. And then if I subtract the 5, 9 minus 5, that will give me the neutrons. So that is 4. I'm using different colors just so you can see it. So 4 neutrons on that one. Back to connect to what we did before, notice its mass is a little lower than the average of 10.81, but we're going to use the mass that we know this atom has. The 9 is specific to boron 9, this atom. All right, boron 10. The atomic number is still 5. Atomic number is the one from the periodic table, so 5. And now this time, though, the mass is 10. So the mass is a little more, so I'm going to do 10 minus 5. And that means, in this case, there are 5 neutrons. Some of you are probably doing this in your head by now, and you don't really need to write all the work out, but we'll do one more together. Still, atomic number is still 5, so 5 protons. And how many neutrons? I'm going to take the mass minus the atomic number, so the mass this time is 11, minus 5, and this time it's 6. And it makes sense that if the mass is increasing by 1, boron 9, boron 10, boron 11, the neutrons are increasing by 1. Boron 9 had 4 neutrons, boron 10 had 5, boron 11 had 6. Because that mass is connected to how many protons and neutrons there are. One thing I didn't do when I was showing my work here is I didn't write out atomic number like we did above. I don't think it's necessary, but I'll just make sure you see that. I guess I'm putting them in a different order, but mass is 9 here because of that. So to get the equation, you just need the atomic number and the mass. Okay, when you get that done, submit it to Schoology 9.2.